The tool that I'm going to introduce next is PerfExplorer. So we saw how to generate performance data with tau. We can create data files for different core counts. We can upload those files to a performance database called TauDB. And then we can use a tool like PerfExplorer to explore how the scaling behavior looks like for functions across different core counts. So then you can focus on at what core count the performance becomes poor, and then you can look into that and explore that further. Here are some examples of running codes on multiple core counts and seeing how different code regions look in terms of scalability at different core counts. There's a runtime breakdown. There are many charts like this that are available. This is PerfExplorer's correlation analysis between two different events. And I'll show you examples of this with PerfExplorer. What this is showing is that if I take two events, just brute force all the different pairs of events, and I say this calc cut block contributions and the MPI barrier event, and I just plot the processor or the rank of MPI between the two different axes, then I can get a correlation plot between these two events. And here it shows me that the correlation is -1, which says that as the time spent in routine A increases on different ranks, the time spent in routine B would correspondingly decrease. And you can get that correlation between those events by just looking at the output. You can also see cluster analysis, where k-means clustering is used, which is saying if I had to put all these ranks in just 2 buckets, then how would they look? If I had to put it in 3 buckets or 4 buckets with k equals 4, then how would this entire set of ranks fall in? We have cluster analysis with significant events. We even have performance regression testing and scalability evaluation. And it's all based on this TauDB. Now, what is TauDB? You see, we can take all the profile files and put them in a database. And then we can create queries. Now, queries on performance data can be high-level queries like what is the mean exclusive time in MPI barrier across different core counts. This is a query. The best way to use such queries is to use a query language like SQL. The SQL supported in different databases is different. They are dialects. And that's why you find that there are big conversion projects in commercial sector when they want to move from say DB2 to Oracle or such. We do support many databases, including DB2, Oracle, PostgreSQL, MySQL, even Cloudscape and H2. Now, in many cases, when you run a database, you need serious resources. You sometimes have a database administrator on a site. You have to open up ports, and it's complex. With H2, an Apache database, you can use file system-based database where concurrent access is permitted. So you can have 2 or more tools or users accessing the same file system based on the file system permissions. So we have a .paraprof directory where we can store the database files. And in this database, the TauDB, we can store the performance data and provide a TauDB interface for higher level tools so they can create complex queries all based on the TauDB API. And so they don't have to code in this low level SQL. TauDB will translate the request down to the SQL based on the backend that is selected, and it will be able to provide the results. So we have PerfExplorer and ParaProf, both these tools that provide access to TauDB. What we will see now is how to use this with the PPK files that we already generate. So the way to use TauDB is that you can, for example, create a PPK file on, say, 2 processor, 4 processor, 16 processor, PPK files that you can compress like this. And then you can either run these tools yourself by saying create default or PerfExplorer configure, or then use PerfExplorer. But we have a data set here, data.tgz, and you can just use this to create a whole database, upload it, and then launch PerfExplorer. And I will try and do that over here. So let me just go to the SRC demo data directory. So I'm just going to the SRC demo data, and then I'm going to the tau subdirectory over here. And here are these PPK files that I already have. Okay. So what did I do? I cd to the SRC demo data tau directory. Cat upload.sh. And it's taking all these PPK files one at a time and uploading it to the database. Then we can launch ParaProf and PerfExplorer and view the data. So I will just do a /upload.sh. Okay. Can you please confirm that this works for you? Yeah, it worked. So it was able to upload the files, create a whole database from scratch, and do this. Okay, just once again, what did we do? There are 2 steps: cd to this src demo data tau directory, and then /upload.sh. Could someone from the online participants just confirm that they are able to do this? Yeah, okay. So next, once it is in our database, any of our tools, whether it is ParaProf or PerfExplorer, they can access the data files. I don't have to be in the same directory because they are uploaded to the database. So I could be in the home directory here, where there are no PPK files or profile data. I can just launch ParaProf over here like this, and I will be able to connect to the database. Now, do you see that there is no PPK file, but it has a manager window that opens up and says there is a database, H2 database, located in the .paraprof perf DMF directory. I can expand this key over here and then see what's in the database. It says there's an application called NAS Parallel Benchmark, and I can expand this, and then I can see the experiment scaling, and then I see all of these profile files. Okay, they have been uploaded twice, in fact. I can open up this, I can double click on time and see the time and see where the time is being spent. I can open up the 3D visualization, I can access this. Now all of this is stored in this .paraprof directory. Okay, and here is .paraprof.
So you're trying to say only one parameter, which is a time for all the simulations, for all the scaling tests?
So time is one metric that we had recorded. You can record multiple metrics like PAPI, level 1 data cache miss, with time, or so in the demo.ppk, I had like 4 metrics that we had recorded. It's just something that you set in the tau metrics environment variable when you run the application with tau exec. So here we had just recorded the default, which was time. So what I'm going to do is, just to start from a scratch, I'm going to just delete this file, this full database, and start again. Here is .paraprof folder. Just delete it all. Okay. Go to the src demo data directory, cd to the tau folder, and then do upload.sh. So it will just upload it once, all 4 of these files. I'm just starting from a scratch. It may take a few minutes to just create the whole database again, so that you're not using a database that was there previously. You'll start from .paraprof and then do this again. So by having a file system based database, it's very easy to do this, because you can just in fact, even some people even take the whole tarball of the database and move it to another system, and they can start using the database by configuring tau. So what did I do? I did this rm-rf.paraprof. I did a cd to this demo data tau, and I did a upload.sh. Okay. Then you can launch Paraprof, you can launch PerfExplorer. This is the second tool that I'll describe. Okay, so can somebody just confirm that they are able to delete the .paraprof directory, go to this tau folder and do a upload.sh, and that it downloads all the things needed and creates a whole new database for you that you can use with PerfExplorer. Is this okay? Can somebody just confirm online that they were able to delete the full paraprof, upload it again? Yeah, okay, great. So I do a PerfExplorer, and in this PerfExplorer, I have this database, and I can expand this. I can see NAS parallel benchmark, experiment scaling, and there's just 4 of these. They're not uploaded twice. They're just 4 of these data sets. I can click on this experiment scaling like this and go to the charts over here and open a chart which says, show me the total execution time. There are many different charts. We'll spend some time looking at this tool, and it will create a chart for you which shows you the number of processors, the total time, and the total execution time. Now, how did it do this? It actually created a SQL query It went to the H2 database, it ran the SQL query, it got the results, and then it plotted it for you. So PerfExplorer is the tool that does that. But to do this, you must select this experiment scaling, this point here, and then go to charts, and then pick these different charts. Here is the aligned bar chart. And I'm just expanding this, and you can see the different do loops on different core counts, and you can see how the application is scaling. So again, let me just recall what I just did. I did cd to src demo data tau directory. Then I did a rm-rf dot para prof. Then I did a upload.sh. Then I launched PerfExplorer like this. And then within PerfExplorer, I did the expand H2 database and expand NAS parallel benchmarks, and then click on the NAS parallel benchmark, and charts, and go for total execution time. Is this okay? And start. So this is just the tip of the iceberg. There is a whole lot of functionality in this PerfExplorer tool to explore. And this is just showing you how you can create the total execution time, then look at some other charts. But remember, you must expand this and click on the NAS parallel benchmark. So PerfExplorer like this. Open this, experiment scaling, open this, so that it's saying that I'm looking at everything under this experiment scaling right here. So these yellow balls are now highlighted. Now I'm going to charts like here, and then picking one of these. Okay. And try exploring some of these charts. If it asks you whether it is a strong scaling or a weak scaling, just say that it's a strong scaling scenario, and then look at the charts over here. Runtime breakdown will show you how this code is scaling across different processor counts for different code regions. So for all of these charts, we are then creating the SQL queries and then running them through this, this tool to the H2 database. So could someone online confirm that they are able to delete the paraprof, upload it, launch PerfExplorer, click on this experiment scaling, and then go to charts and pick some of these charts like total breakdown, total time breakdown? Okay, great. And it's working properly for you, right? I hope you can all try some of these charts, and we'll see some new views that PerfExplorer can show you. So just to take a step back, you can easily create a profile data set in an uninstrumented application by saying, tau exec-ebs a.out. You create PPK files from there, like paraprof --pack zoltan 4 processor.ppk, 16 processor.ppk, 32 processors.ppk, and then you can use this script like upload.sh to upload the files, the ppk files, to the performance database, the H2 database. Then you can launch Paraprof to view them. You can launch PerfExplorer to view them. You can actually launch them both together because of the H2 database. And then you can see charts like this. Now, until now, what we used to do is, when you used to want to create a chart for performance for your, say, a paper that you're writing, you would typically do a get time of day call to identify a code region, right? And then you would do a print statement, somehow do the MPI reduce call, get one number from each processor count, and then you would cut and paste that number in an Excel spreadsheet. And then whether it's Excel or GNU plot or something, you would then use that to create plots for different code regions to show scalability. What we are trying to show here is that you don't need to do all that. Once you have a tool that can generate the profile data, you can just submit that and store it in a database. And then with a tool like PerfExplorer, you can access it and you can create custom charts for yourself and then see the scalability of the tool, the scalability of the application, and generate any charts that you want by just accessing the data through a graphical user interface without writing a single line of SQL code. Okay. So please try some of these views in PerfExplorer. We'll take a few minutes to try that. And then I'll show you some custom charts and how we can create that in PerfExplorer.
Might I ask a question about PerfExplorer?
Yes.
Can we get the chart data in a I guess a more raw form, like a file that we could then put into whatever we normally use for charting if we're preparing papers and the like?
If you're asking whether you can export the data, the answer is yes. You can export it in a column separated tab format or CSV format, and then you can use it in any other tool too. Yes, you can.
That's
you can
exactly
do
what
that.
I was asking. Yep, thank you.
Yeah. And you can also add metadata to a file after the application has finished execution or during execution by using a tau metadata environment variable, which has key value pairs that you can associate. So you can inject that metadata along with the application data and store it in the database. And then you can even retrieve those fields that you have defined yourself to create custom charts using PerfExplorer. So you can use it to, for example, if you had a application specific parameter such as the number of iterations in a particular run, you could store iterations as a keyword and then give a value in the metadata which is like 1000 iterations. And then you could have multiple runs with different values of iterations and then plot that as one of the fields. And with the PerfExplorer, you can have custom charts. So you click on this red ball which says custom charts, and then you can pick any data that's there in the database. So I'll come to that soon, but let me just give you a few minutes to try this and see that you are able to launch PerfExplorer. Open up this hierarchy to go to experiment scaling, click on this, go to charts, and then pick one of these charts like this.
To follow up on my previous question, PerfExplorer might be the wrong tool, but is it scriptable? Having like used the GUI to explore what I might want to do, can I then make a script so I can do it repeatedly in an easy to reproduce manner?
Yes. So both ParaProf and PerfExplorer have some charts, but these tools are actually quite open, and they provide a Jython interface, Java
Cool.
with Python, where you can
Yep.
create your own scripts and then create either specific charts, and you could say, I want a chart which shows how a test ran over the last 5 months, and then create a PNG file, save it in this file name, and then push it onto a web page where you can show the PNG file every night or something like that. So you can totally script these tools using the Jython interface. It's a very powerful mechanism to actually make these tools extensible and to create custom visualizations. And we can have someone in our team help you with showing you how to do that with a simple case. You remember I had showed custom topology views that we have, where you can load ParaProf and then pick any file that describes the formula that shows you how to visualize a particular data set. In the same way, that's an example of loadable topology. Here we are saying you can pretty much script anything that ParaProf and PerfExplorer provides using that Jython interface and script it instead of launching the GUI, and then just save the data in a PNG file and then ship it off to some web page.
That's fantastic. Thank you.
Oh, thank you. So were you all able to run this experiment? Were you able to launch PerfExplorer, look at the different charts, like this stacked bar chart? I want to give everybody just a minute or two to try this. Once you're done, please let me know. I'll go on to the next feature of this custom charts. Oh, good. Sam says he successfully ran some charts. I've had some users who create a whole hierarchy of all their results across multiple machines, and then they create this whole H2 database, which is just perfectly set up with all the different PPK files uploaded to them, and then they just go to the .paraprof directory, the perfdmf subdirectory, and just tar it all up and move it to another system or share it with their colleagues or just store it, and then they are able to just access it in a different machine with the database. The files are sometimes small enough that they can even email it to a colleague, the full tarball, and they can just expand the tarball, do a PerfExplorer, configure, point to that directory, and they are able to launch these tools by sharing the full hierarchy of all the experiments they have run. So here I have a custom chart. Now suppose I'm interested in plotting just a few events and not everything. And I want to show how that event is timed across multiple core counts, then I can do this. I can say I have to give a custom chart. I don't want just main, but all the events over here. So let me just arbitrarily pick some events from this list and say I'm interested in, say, 4 of these events. So I'll click here and press the shift button and do a multi-select for only these events, okay? So I'm saying I want to look at the performance of these events, and I'll give it a chart title. I'll say my favorite events. And this is y-axis is, say, exclusive time. And the x-axis is number of cores. And I can say x-axis and take this drop-down menu and pick threads of execution. Okay? And I pick the threads of execution. I say the y-axis is exclusive time, mean exclusive time. I can pick anything else. And I'm just interested in these 5 functions. Okay? And I want to plot this and maybe create a vector graphics file. And I want PerfExplorer to create the SQL query, which says select mean exclusive time across the different threads of execution. For these 5 functions, retrieve this data from the database and then give this to me. I will do a strong scaling value chart and then I will plot it for you. What am I plotting? I'm plotting number of cores because I've chosen the threads of execution. I've got the mean exclusive time over here. I've got these functions. And then I'm showing the value of this with respect to the strong scaling. And I'm going to just click apply. When I click this button, it will formulate the SQL query. It will then send that SQL query to the database. It will retrieve the results. It will plot it for me. And I click this apply. And there is the my favorite events. These are the 5 events. Here are the core counts, exclusive time in seconds. And I didn't have to write a single line of SQL code to generate this plot. Now, I may not like this because it's the total core counts are going in this way, where the distance between these are not what I wanted to see. I could just click this and say, I want categorical x-axis, and I click it again. So the distance between those is now 8, 16, 32, 64. So the distance is better. If I still don't like it, I say, hey, can you angle the x-axis labels? So they are not like 8, 16, 34, and then you get the idea. I can click it, it will create this, it's angled the labels, it's put a categorical x-axis, and then I can just right click here and either save it as a PNG file over here, or I can take this file, save as vector image, full window, metadata, an EPS file or an SVG file. So if I take this and say scaling of 5 events dot EPS, and I click this, it will save that as an EPS file where all of these labels and the data are stored as a vector, not as a PNG. So if I pull this into my paper that I'm writing, and I just get the EPS to be used for a LaTeX paper, then the files will look, the images will look very crisp. If you're creating a poster for a conference, then you have the scaling data that you have received from this, you can scale up those images really well because they are all vector, EPS or SVG files generated at source from PerfExplorer. So it changes the workflow. This takes us away from cutting and pasting output from a print statement manually and putting it in an Excel spreadsheet or a matplotlib file, and then running this tool like Excel to create the charts, saving them as bitmaps, importing them into your posters or files or your papers. Instead, you are able to do this full workflow automatically by just uploading the PPK files to the database. Then using this custom charts view, you can pick what you want to select and give the x-axis, y-axis, labels, and then you are able to just generate these charts that you can then save as vector images. So I'll just wait a few minutes and have everybody try this custom charts. Click on strong scaling, click on this x-axis value to be threads of execution, give a label here, uncheck this main only box so that you can see all these events, multi-select some of these, put the x and y-axis labels and click apply and get a view like this. Once you try it once like this, you'll see the full power of this tool to be able to pick any data from the database without writing a single line of SQL code and having the TauDB write out those commands for you. And after lunch, we can look at the correlation results and cluster results and follow up. But I hope you're able to do this. And if someone from the online team can just confirm that they are able to create custom charts, that would be great. Thank you, Angus and Stephen. Sam. So should we break for lunch now? Okay, we can break for lunch now. I have a question here.
So I can see there are two video about weak scaling and strong scaling.
Yes.
So if the runs are meant to be like for a specific scaling test, how can you select these two of them and run your case for a particular case? Like you cannot have an explicit tagging of doing big scaling or strong scaling.
So we have some charts that are specifically showing the scalability curves. And so for that, they need to know whether it is a strong scaling or a weak scaling so that you can pick that in the analysis, charts over here. And that's why it is just provided, so that there are these scanned charts that you can then experiment with and see the scalability, so that you can see an ideal curve and then where you are. So you can see how far behind you are from the ideal. And we'll come back at a few minutes past 1 p.m. Western Australia time. Is that okay? Yeah. We'll break for lunch about an hour and then resume. Thank you very much.